Hey everyone, the Simplified Engineer here. Today I'm going to go over the basics of statics. This is lesson one, module one. What is statics? Have you ever wondered how a bridge doesn't fall down or a skyscraper doesn't fall over, or how engineers even start to do the calculations to design bridges? Well, that's all thanks to statics and math. Statics is the study of forces in equilibrium where objects are at rest or moving with constant velocity. The forces and moments are balanced. For example, the sum of the forces and the sum of the moments are both going to equal zero. If they don't equal zero, then we get what's called dynamics, and that's a completely different subject that we're going to study later. This graphic is a classic example of statics. For every force, we have an equal and opposite force. This is to say that the sum of the forces equals zero. In this case, gravity is equal to the normal force opposing the table. When there is a table and there's gravity pulling down on it, there is always an equal and opposite force pushing up on the piece. If there wasn't an equal and opposite force, this box here would fall through the table. The same applies for friction. Since this mass here is not accelerating, it's sitting in one spot. If we applied a force to one side, there would be equal and opposite force keeping it from moving in the friction direction. This is to say that the sum of the forces equal zero. Let's get started with a classic statics example. In this example, we have a 10-kilogram mass hanging from a rope, and we want to find what is the tension in said rope. For metric, the standard unit for gravity is 9.8 meters per second squared. For this example, the first thing we're going to look at is the forces on the mass. The mass weighs 10 kilograms, as we determined before, and the main force we have is gravity. Let's do F sub G to say force of gravity. There's a second force acting on this because if there was no upward force, the mass would be infinitely falling at accelerating speeds in the gravity direction. This upward force we're going to call force of the rope. We're also going to set a coordinate system. We want to say that the vertical direction is positive. To make this easy, we can calculate the force of gravity right here on the screen. The force of gravity equals ma, or in this case, mg, since the acceleration is equivalent to the gravity, at 9.8 meters per second squared. And this equals the mass of the block, which is 10 kilograms, times our gravity, equals 98 newtons. Just keep in mind that some instructors prefer to use 9.81 meters per second squared, and that would just give us 98.1 newtons. Great, so we have the main force done. We know our force gravity, and we have one more unknown, the force of the rope, and we can plug that into our equation over here on the left side. As I mentioned in the previous slide, the first thing that we're going to do is say sum of the forces in the vertical direction equal zero. As we identified before, we have two forces, force gravity and the force of the rope. And if we look at our arrows on the force gravity direction, it's in the negative direction from our coordinate system. So over here in the sum of the forces, we say negative Fg, negative force of gravity, plus the force of the rope. The force of the rope is positive because our vertical direction is positive. Force of gravity is negative because our vertical direction is positive and gravity is heading in the opposite direction. Let's simplify this equation a little bit more. With basic algebra, we can now say that force of gravity equals force of the rope. And we already solved for force of gravity over here on the right side. And that means, and force of gravity is 98.1 newtons, which equals the force of the rope. Let's look at a problem that is slightly more complex. In this problem, we have two masses, mass 1, which weighs 10 kilograms, and mass 2, which weighs 5 kilograms, hanging from rope B and rope A. This example is asking us to find the tension in rope A and the tension in rope B. Let's first start by defining a coordinate system where the vertical direction is the positive direction. We're also going to draw our free body diagrams and our masses. So let's start with the force gravity for mass 1 and the force gravity for mass 2. As we discussed in the previous problem, there's also a vertical force acting on mass 2. This is force of rope B. And there's a vertical force acting on mass 1, which is the force of rope A. There's a problem here. We don't account for mass 2 pulling down on mass 1. We have force gravity, but no force from rope B acting on mass 1. To do that, we have to draw another arrow, and we can say force of rope B. And you'll notice here, we have two force of rope Bs pointing at each other. This allows us to do a really cool thing later in our sum of the forces equals 0 equation. Speaking of that equation, let's get that started now. So we have the sum of the forces in the positive x direction equal 0. Let's count all of our positive forces. We have force of rope A, and we have force of rope B. So now we have force of rope A and force of rope B. And now let's count the negative forces. Force of rope B, force of gravity of mass 1, and force of gravity of mass 2. So minus force of rope B, minus force of gravity of mass 1, minus force of gravity of mass 2. And look what we have here. We can just cancel out our force of rope B's because we have equal and opposite acting forces, and they negate each other out. So I'm going to rewrite our equation with force of rope A on the left side, and keep force of gravity of mass 1 and force of gravity of mass 2 on the right side. We have 3 negative signs, and we can make this positive. And from the previous problem, we know that the generic formula for force is MA or MG in this case. So force of rope A equals mass 1 times gravity plus mass 2 times gravity. And we can factor out the gravity in this case. So it's gravity times mass 1 plus mass 2. And that gives us force of rope A equals 9.81 meters per second squared times 10 kilograms plus 5 kilograms. Now let's just solve for force of rope A. And that gives us 147.15 newtons acting on rope A. To solve for rope B, we can simply, to solve for rope B, this is very similar to the previous problem, where we can just identify a smaller coordinate system here, saying this is coordinate system 2, positive direction is upward, and we can say sum of the forces of system 2 in the positive x direction equals 0. And we only have 2 forces acting in our second coordinate system, force of rope B and force of gravity 2. Force of rope B is positive, minus force of gravity 2, and bring force of rope B over to the left side equals force of gravity 2. And we know gravity 2 is equal to mass 2 times gravity. And that means that force of rope B is equal to 5 kilograms times 9.81 meters per second squared equals 49.05 newtons. And that was our first video in this module of statics. Please let me know if you have any questions down below, and I hope you enjoyed.